Hello guys, welcome to today's LeetCode challenge. We're going to solve this LeetCode sort an array. So you're given an array of integers nums, sort the array in ascending order and return it. So you must solve the problem without using any built-in functions in O n log n, time complexity and with the smallest space complexity possible. Okay, so input nums is equals to this, output is equals to this. After sorting the array, the position of some numbers are not changed. For example, 2 and 3, while the positions of other numbers are changed. For example, 1 and 5. Yeah, you can see, in short, you've been told that you need to sort an array without using any built-in function, right? And also you need to sort it with O of n log n. So in short, you can perceive it as just create for us a sorting function, just similar to the one that is currently there. Okay, so we can start building it. Let me do this way. And okay, let me try to zoom it a little bit. I will do this. Yeah, I'll start with giving examples of what I'm thinking and how we can go about this solution. So for example, I've been given nums as 5231, right? Will be given as this. So you want to return the result in this format: 1 2 3 5. Yeah, you cannot notice that 2 is not it is in place, so we haven't changed anything with 2, but we have changed 3 and 5 from here, 5 and 3, and also 3 is not actually, you have only changed 5 and 1, right? Okay, so you must solve the problem without using any built-in function. Okay, if this was not the case, we could just return sorted. Sorry about this. You can just return sorted and then nums, right? But now we have been asked not to use any inbuilt function. I think we can use merge sort for this. Merge sort is more of divide and conquer. So for example, I've been given 5 2 and 3 1. If I'm to construct a tree, will be like, I want you to divide the array until where it's not divisible, where you cannot divide again. So we'll divide the array to this 5 2 3 1. This will be the first division of the subdivision of the array, and then it will reach a point where we have multiple values. For example, here we only have one value in the array. At that point, we need to check if 5 is greater than 2. If that is the case, we swap. Maybe you can swap 2 and 5. Yeah, so this one now becomes 2 and 5, and then the same way is 3 greater than 1, which is true, 1 and 3. Yeah, we'll be doing that, and then we merge it. Now we have this, we try to merge. Now how do we merge is we try to see if there are values here that are greater than values that are here. So we can loop through the elements here and say, is this value greater than this one, which is true? So we update. So we have now 1 here, 1 5, and here now we have updated because 2 is greater than 3, so 2 greater than 1, so we have 2 and 3. And then we go to the next value, 5. Is 5 greater than any of these? It's true. So the next operation will be 1 5. Sorry, it's greater than 2, so we'll start with 2, and then we replace here 5 and 3. And then when you get into this array, is 5 greater than 3? Yeah, it's greater than 3. So the answer returns this way. Yeah, so this is the idea. We can just merge the list into the array into small subarrays, and then we can start to try to sort it. Okay, I will start the implementation, and let me first start the timer. Yeah, the timer is started. So First of all, I said that we're going to use merge sort, so I will create another method here, merge sort, and also we're going to do merging, so I'll create another one here, merging, and what I want to do is to return the value that is in the merge sort this way. So we have an array, we want to subdivide it, so in short we will need the left pointer and the right pointer. The left pointer will start with 0 and the right pointer will start at the length of the nums -1. Yeah, so in merge sort we will expect to pass the left and the right because we're going to go through this element subdividing. So each array, each subarray should have its left and its right. Yeah, so that's why this merge sort should have left and right. Okay, so we're going to return this one. So in the merge sort, what I want to do is to compare if L is less than if the left pointer is still less than the right pointer, meaning that, for example, the left pointer is 0, the right pointer is 0, 1, 2, 3. Yeah, so if it is still less than the right pointer, it means that we can subdivide its array again into small arrays. So I can say we can, because now we have one, we want to subdivide into small or half of the array. So in that case, we need to have another variable called mid is equals to L plus R, and we don't want any float variable, so we use this command, this operation. So after that, we want to merge sort elements in the left part of the, so I will say the left pointer will still be the left pointer, but the right pointer will be at the mid. So in this case, what I mean is we are taking the first two elements because the mid will be here, around here. So we're taking these elements and we're merge sorting again. So next one is from the mid pointer to the right pointer. So this will continue, and after that we'll try to merge. So in the merging, we want to merge, we will need the left pointer, the mid pointer, and the right, because we want to know, we want to merge from this element to this element, for example, or maybe 5 and 2. We want to know which is the mid, where is the left pointer, where is the right pointer, so that when we are merging, it becomes easier. So we merge the array, right? So we can do this in place. Actually, we can do this in place, so we don't need to return anything. So here we can should we do it in place, or we can just do merge sort and then return the return. Let me try to do it in place, return the nums. So we have already finished the merge sort function. So when I come to the merge mid right, so what I want to do here is to first thing, okay, is to, in merging, as I said, we want to compare if this value is greater than this value. For example, this is the first subarray. We want to sort it first before we go to the next. So in that case, I will try to create a new subarray. Do we really need, but let me try to create a new subarray. So I will say temp left array is equals to elements from the left pointer to the mid pointer, and temp right array is equals to element from the mid pointer to the right pointer. Yeah, so after this I can have some variables ijk just for looping through the elements and checking if the values are equal. So ijk is equals to, we be starting at 0, but k is where now we are updating the values in the in the nums function. So here we should set it to the left pointer. Okay, so I will say while I is less than the length of the temp left array, and G is less than the length of temp right array. So what I need to do is to check if the value at the left part I is greater than the value at the left. Okay, this is temp right a. Okay, temp right array G. If it's greater than that one, if this value is greater than this one, now we need to you get it, we need to update the value. So in this case I will say, okay, array, the array at k, because k now we are at the left pointer, we want to update from the left pointer. Array k is equals to temp left array, and then we update to I, right? And then we, okay, this k should be incremented it regardless. So for that I need to, because it's I that was greater than this one, I need to increment now j, right? Because I want to see if there's another element here that is less than 5. So in that case I need to increment j. Else, let me do this, else I need to, it's the same, array k is equals to temp right array G, and then we will need to increment I. Yeah, this way. So after everything is whichever the scenario, we need to increment k, because again k is the variable that defines where you need to update the values. So after this I want to check. There are some cases where the temp left array could be less, the length of it could be less than the length of temp array. So there are some values that have not been added. So in that case I will say while temp left okay, while I is less than length of temp left array, what I want to do is to at long last I want to update I, and again I want to say array k is equals to temp left array I, and then after that I need to increment k. So I'll do the same for j, it's less than the length of temp right array, and then array k is equals to temp right array, and then g. So I need to increment j and also increment k. Yeah. So after this, the merge sort is the merging is complete now. As you can see, we are comparing here if the left value is greater than the right value, and yeah, we are using these temporary left arrays and right arrays to check. For example, if we have 5 and 2, just for test cases, if we have 5 and 2, the temp and the mid of course will be 0. So the value at the temp left array will only have a 5, and the temp right array will only have 2. So we'll compare if temp left array, this one 5, is greater than the value here 2, which is true. We need to update the value at k, because at k it is at the left pointer. In this case the left pointer is at 0, so we need to update the value at 0 to the value that is. I can try running it just to see if everything is in place. Let me try running it and see if there is an issue. runtime error. Okay, what's the issue? Okay, on line 39. Oh, what did I do? Nums -1. Let me try to see if I got something. Array is not defined. Oh, it should be nums. I'm used to array. Anywhere I used array. Now let me try to do this. Okay, let's try to run. Wait a minute, can't I run now? Yeah, let's try to run. Oh. Wait, nums. I'm used to arrays, sorry about that. Let me update it and let me run. Okay, so the output is 555. Oh, I see where I've missed. I think if the value is greater than template A, then nums k, it should be this value here. I don't know what I'm doing here. It should be template A. What am I doing? And it should be template A. Yeah. Let me proof check another one. If I run it, yeah. So you can see now it is working as expected. I've used 18 minutes. If I try to submit, try to see if there are any errors. Yeah, you can see the application, the solution is working fine. And yeah, thank you.